This is the map reading features. What features it is? Yes, these are the features: counters, combiners, partitioners, sorting, joining, site data, distribute, cache. These are advanced features. Why? What are these features? Why we are using these features? As by using these features, we improve the performance of the MapReduce code. We are going to improve the performance. Let's see first one, counters. Counters are useful channel for gathering statistics about the jobs, for quality control or for the additional level statistics. If I want to find out the jobs, here counters are the, what do you mean by counters is, counters are the useful channel to find out the statistics about the job. Statistics about the job. That means, for example, my job is going on. I want to know the status of the job. We had different layers used in the map producing. Data reading stage, after reading mapping stage, then intermediate shuffling starting stage, then reducing stage. Like that, different stages is there. I want to find out which stage it is. Yes, we have the concept called the counters is there. There are two types of counters is there: built-in counters, user-defined counters. Built-in counters means inbuilt counters, it giving the status about the each and every task. For example, data reading time. What is the status of the reading? File system counters. Everything is displaying each and every task status. At the same time, user-defined counters is there. What do you mean by user-defined counters? These counters are global. The MapReduce framework aggregate them across all maps and reducers to produce a grand total at the end of the job. One job completed, I want to find, yes, display the message, yes, job completed. I don't want individual level. That we call the user-defined counters. So simply, we are using counters in our MapReducing to find out the job status. Next one, combiners. What do you mean by combiner? Especially, we are using this combiner to improve the performance. To improve the performance of the MapReducing, we are using combiner. What is combiner? Combiner means simply to combining the data, right? Same meaning here also, combining only. Where we are using combiner feature? Yes, mappers produce large amount of intermediate data. Right now, our data is small data, DR1, BR1, reverse, just like a 9 records. But in the real time, mappers produce huge volume of data. That data we call it intermediate data. That intermediate data we are passing to reducer input. Sorry, that intermediate data we are passing to reducer input. Yes or no? So here, yes, mappers produce large amount of intermediate data that must be processed to the reducer. This can be result a lot of network traffic. I want to decrease the network traffic. At the same time, it will be burden on reducers. It will be burden on reducers to doing the work. So here my requirement is I want to decrease the network traffic and I want to improve the performance of the reducers. If the performance of the reducers increasing, means performance of the MapReducing is increasing. Alright. So that's why I'm using combiner concept. Yes, it is often possible to speak like a combiner. It's act like a mini reducer. A combiner acting like a mini reducer. Where this combiner is available? Yes, this combiner is available after mapping phase, before reducing phase. See the code also. Where is our code? Yes. Combiner is there after mapper, before reducer. After map phase, before reducer. Okay. What is the work of combiner? Yes. The main intention of combiner is combine the data. The combine, what are the mapper gives output? That mapper output combined it. That combiner output now we are sending to reducer. So simply for example, for understanding purpose, see the second box, car, river is there. That meaning here two cars, two separate arrows going to shuffling input. Two separate arrows. Instead of two separate arrows, combiner running internally here only. This combiner combine the data, one arrow only going to reducer input, shuffling input. each and, each and every mapper, each and every mapper output combine is running. That combined output we are sending to reducer input. What is the main use? Yes, as much as possible we combine the data. That combining output we are sending to reducer input. We decrease the network traffic, we increase the performance of the reducer also. Then next point, partitioners. What do you mean by partitioner? What do you mean by partition? Partitions means to categorizing, right? Why this partition we are using? Generally in our hive we are using partition. Yes, why? To improve the performance. Similar in our map reading also, the partition concept is there. By using partitioners, we are going to improve the performance of the map reducing. I'll give the requirement. For example, I have some employee details is there. I want to report male employees, female employees accordingly. How can we give the output? Another requirement, second requirement. I have male details is there, employee details is there, and I have less resources. Just 2 reducers only available. My cluster is busy. My colleagues are already busy with some other work. I don't have less resources. Okay, just 2 reducers only available. 2 reducers only I want to use. So all male employees go to reducer second, female employees go to reducer 1. I controlling my data output also. How can I? By using partition concept. Yes, these partitions are divided up into key spaces. Controls which reducer each intermediate keys and associated values goes to. Okay, and often the default behavior is there. Here is find default hash partitioner, where different types of partitions is there. We're using hash partition is the by default partitioners. How to implement partition concept in our MapReduce code? How to implement? This is the code. Public class name. You can take key to v2 anything and implement partitioners. If anyone asking how to implement partition in our MapReduce code, simply say by the implementing partitioner class. By the implementing partition class, we are implementing partition logic in our MapReduce code. So this is the one. Just here, account key, we are dividing into key spaces. So this is by partitioners. At the same time, we have custom partitions also is there. Custom partitions to implementing our own logic. Then next concept. Sorting. Yes. What do you mean by sorting? Where the sorting concept is came into the picture? In our map reducing flow, where it came into the picture? Yes. After mapper, before reducer, the framework doing sorting. Yes or no? Agree. As a developer, we're doing a small thing, but internal framework doing a big thing. After mapper, before reducer, sorting is there. What is the sorting doing? Yes. Throughout sorting is done at sorting and shuffling phase. In the sorting and shuffling phase, the sorting is happen. There are different ways to achieve the control the sorting. By default, it's going to the partial sort. Partial sort. This is the by default sorting. If you're not specifying any sorting techniques, automatically framework taking this sorting. At the same time, if you have any special requirement, we can control the sorting also. Each and every part we can control. See, by default, the mapper is doing a lot. And if you have requirement, you can control. You can control that parts also. See, for example, we have 3 types of basically we have 3 types of sortings is there, namely partial sort, total sort, secondary sort. There are 3 types of sortings. The partial sort will take the responsibility. This is partial sort, the first one. This is a by default one. This is a default map reducing job. Will sort the input records by keys, and if there are 30 reducers is there, 30 sorted files will be generated. These files cannot be combined to produce the global sorted files. 30 files, 30 reducers, 30 sorted files will be generated by default one. But we have another one is the total sort. What do you mean by total sort? Usually one reducer. When usually you have only one reducer, that time we are using total sort. It is very inefficient for large files. I have big data is there. The total sort is not the good solution. But you have less resources. You have less resources. You want to control sorting. You can control by using total sort also. So what is the total sort doing is, if you have 30 reducers, you have 30 files, but this total sort generating only one file only, one sorted output only. But partial sort is generating 30 sorted output files. And similarly, you have secondary sort is there. What is the secondary sort is? For any particular keys or values are sorted. For example, previously I showed in the partitions, male employees or female employees. Like that, I want to control the keys. Based upon the keys I want to sorted. All male employees only I want to sorted. All female employees only I want to sorting. I want to group. Sorting means to measure the data, right? So by using secondary sort, we can do it like that type of sorting, controlling the sorting concepts. If you write our own MapReduce codes, for example, if you write your own MapReduce code, yes, internally joins concept is there. The joins concept means is a joins. Joins means we know like to join the data, perform the joins operations. So the joins is performed the mapper side. That joins we call the mapper side joins. The joins we perform the reducer side. That joins we call the reducer side joins. There are two types of joins is there: mapper side joins, reducer side joins. Okay. Mapper side joins means, see, the mapper side joins between the large inputs works by performing the join before the data reaches to the map function. And the reducer side joins means the reducer joins is less efficient. Is both the data sets have go through the map reading shuffle. Okay. Here a question is there: if the map reading is running on, generally mapper take more time or reducer take more time? Inter time also people are asking. Reducers taking more time. Yes, as of now, imagine we have the joins concept is there now. Because of the joins, it's taking the more performance. Reducers taking the more time to process the data. And it's the joins in the reducer side is less efficient again. And joins in the map side, like more important reducer joins. Right. That is the joins. So the coming to the next one, distributed caching. Again, this is one of the important feature for a map reading concept to improve the performance. What do you mean by cache, first of all? What do you mean by cache? We know cache concepts in our regular days we're using. For example, if I'm logged into the Gmail, if I create a new Gmail, very much first time it takes some time to log in. But second time onwards, it's not taking much time. Why? What is the reason? Some cache technique is there. Sections is there, temporarily our data is loading in the sections. It taking care, it's validate our credentials. That is a cache concept, right? Similarly, in our Hadoop also we have the distributed cache concept is there in our mapping concept. What do you mean by distributed cache? The main intention of this distributed cache is to improve the performance of the program. Okay, how to improve the performance of the program? I will tell you some real-time scenario. For example, I want to find the performance of the employee. I have a number of employees is there. I want to find the performance of the employees. How can I categorize the performance? How can I decide the performance? How can I give the CRR level, performance bonus? I want to consider so many factors. First thing is, I want to consider his code deliveries. What is his performance or what is the code deliveries? In-time deliveries is there or not? Activities. And again, what activities is performed other than project? Is there any other activities? Is doing any seminars? Is publishing any papers? And his team activities? So many factors I want to consider it. So just imagine all my code deliveries main data is there in data node 1. The data is the distributed cache. Distributed cache means distributed data means our data is the multiple data nodes. Some data available data node 1, some data available data node 2, data node 3, data node 4. Just for understanding, data node 1 is there our code deliveries that information. Data node 2 is our extra activities. Data node 3 like our public some other information. Data node 4 some other information. Like the 4 data nodes, my data is available. Now I want to find out the performance of the employee. How can I find out? I consider the 4 data nodes data Then only finally I find out, yes, this is the employee, this is the performance. I can find out. So here, what is the meaning of distributed caching? Instead of running 4 data nodes, 4 mappers and 4 reducers, instead of running 4 mappers and 4 reducers in the 4 data nodes, same purpose. The distributed cache concept is copy the data from other data nodes data to the our main data node. Main data node means this is the large quantity of the data available here. Large quantity of the data available here, and I want to generate these reports. I want to consider remaining data nodes data also. For this purpose, we transfer the data from the other data nodes data to our main data node, and here we are running a single mapper here. Then we will find out, yes, this employee this much CRR, so we are giving this much of bonus. Another employee that much of performance. We are deciding accordingly. So same concept is there. Yes. This transfer happened behind the screen before any task is executed. What is the transfer is there? This transfer is just a logical. There is no physical. Once the process completed, automatically, whatever transfer we are taking those data will be terminated automatically. See, transfer happened behind the scenes before any task is started, executed, and distributed cache is only read-only only. Files in the distributed cache are automatically deleted from the slave nodes when the job is finishing. My job is completed automatically. What are the data we are reading it? So data node, those data automatically deleted. Okay, that we call it distributed cache. Okay, now we got it. Why the distributed cache? How to implement this distributed cache in our program? Yes, this is the code here. In our main method, job main new job conf, then mention which data nodes wherever data is available. Mention those path here. This is the class distributed cache dot here distributed cache. This is the package dot add cache file, the file path, then class path. Whatever files if you want, completely add here in our main method. That's it. That is called a distributed cache. Okay, and remember this just like a read only. There is no physical transaction. There is no physical data moving. Just for temporary purpose, just reading the data. Once our job is completed, automatically the data is terminated. This is another approach to improve the performance. Why I'm telling all these points is, yes, maybe we get the chance or not to working on map reducing, but intro time definitely they're asking what is the performance, what is the features to improve the performance of the map reduce codes.